Good afternoon. Uh, Today I am going to start set. Of course, I am teaching this set for class 11th CBSE mathematics. But at the same time, I will correlate the facts, formula, and high definition of NCERT textbook and NCERT exemplar, from which the question in different competitive exam like IIT, entrance, NDA, etc. are framed. So that's why these classes are very important to the students, those who are preparing for CBSE exam, IIT, NDA, etc. Now, first of all, I would like to mention the contains the syllabus which I will teach you. Number one is sets and its representation. In order to teach set, we often come across with the collection. We, from day-to-day life, we are always using this word, the collection of objects of a particular kind. For that, you can take the collection, a pack of cards, a crowd of people, a cricket team, etc. In the same way, in mathematics also, we come across with the collection. Now, I am putting some example of collections. First, this is my first example. Set of collection of odd natural numbers less than 10. Odd natural numbers less than 10. That is 1, 3, 5, 7, 9. This is one of the collection. This is not a collection. Just you have written the, first of all I would like to explain the difference between just writing the elements, writing the members with commas. That is not the collection. When you want to write as a collection, you have to write inside the curly braces. Now this is the collection. Next one, the rivers of India. Second example. The rivers of India. Third, the vowel of English alphabet. Fourth, various kind of triangles. Fifth, solution set of the equation x square plus x minus 2 equal to 0. So now you can see the rivers of India. You may write Ganga, Jamuna, Saraswati, Ghagra. All rivers are in India that are the member of in this set. And odd natural number less than 10, 1, 3, 5, 7, 9. The vowels of English alphabet A, E, I, O, U. Various kind of triangles, scalene triangle, isosceles triangle, equilateral triangle, right angle triangle. Collection of various kind of triangles is also a collection. Solution set of the equation x square plus x minus 2 equal to 0. First you solve this coordinate equation and find the value of x. Your value of x is minus 2 and 1. And when you write like that, now this is the collection. Now whether all this collection are well defined or not. Now question is that whether all this kind of collections are well defined or not, this is important. In first case, you observe that this is well defined. Reverse of India, this is well defined. The vowels of English alphabet, this is also well defined. Various kind of triangles, this is also well defined. Solution set of equations, this equal to 0, is also well defined. So maybe one thing is in our mind that if all this are well defined, though how can we write the collection that is not well defined? For that, I am taking a collection of seven most renowned mathematician of the world. Of the world. Now you see, most renowned mathematician of the world. This is seven most renowned mathematician of the world. This collection is not well defined because of the definition of most renowned mathematician is vary from one mathematician to another mathematician. Most word is not well defined, that is not defined the limit of its greatness, its achievements. So this most word we cannot define in that way. This collection of seven most renowned mathematician of the world is not well defined. And in other cases, previously which I have given you 5 examples of collection, they are well defined. So after doing all this kind of exercises, we reach to the high definition of the sets. How can you define, how can you give the definition of set? Set, it is a well defined collection of objects, items, or things. Now we reach to this definition. One thing is that set is represented by, now we come to representation of the set. Representation of set. Set is represented by capital letters of English alphabet. A, B, C and so on. X, Y, Z. And their elements are by small letters. A, B, C and so on, X, Y, Z. Now, concept of belongs to and does not belongs to. I am taking these two things. For belongs to, the river Ganga belongs to India. Ganga belongs to, this is the symbol, this is the symbol, belongs to. Belongs to India. The river Nile does not belongs to India. Nile belongs to, does not belong to this, India. Nile does not belong to India. In this way, we can understand the concept of belongs to and does not belongs to. So, when I write a set of natural number less than 10 as set A 1, 2, 3, 4, 5, 6, 7, 8, 9. So this collection of natural numbers less than 10 is a set, and the elements, we are writing the elements of the set in a row by separating them with commas like this. And if you want to find out the number of elements in this set, so it is number of element in A, that is equal to 9. Number of element in A means you count the number of element present in this set, you count it, and number of element in A is denoted by Na and of A in this way, and you must write Na equal to 9. Now, some notations to identify the different kind of sets. They have some notations. Some notation for different sets. Number 1, and they use capital N for set of natural number. Second, Z, the set of integers. Third, Q, the set of rational numbers. Third, R, the set of real numbers. Fourth, fifth, Z plus, the set of positive integers. Sixth, Q plus, the set of positive rational numbers. Seven, R plus, the set of positive real numbers. That is the sum notations to denote the different sets. Meaning of representation of sets. Representation of sets. Meaning is method to write a set. Representation of set means method to write a set. First method, roster method. This method is also known as listing method, tabular method, in this method what we are doing, in our collection we are writing the element of the set in a row by separating the elements with a comma. For example, set of even natural number less than 10. 2, 4, 6, 8. These are the even natural numbers less than 10. Set of even natural numbers less than 10. They are 2, 4, 6, 8. And we have listed this method. In this method, we have listed the element of the set 2, 4, 6, 8. This is called roster method. You may call it as listing method, tabular method. And now second is set builder form. Set builder method. In this method, the set is represented by characterizing property Qx of the element x. In this method, the set is represented by characterizing property Qx of the element x if all the values of x for which condition Qx is true is the set representation in set builder form. For example, A is defined as all x such that Qx, or you can say A is defined as all x such that Qx. In this case, this or this symbol is read as such that. Now example, write the set A write question, write the set A equal to 1, 4, 9, 16, 25 and so on in set builder form. Now you see in this, if x is an element of this set, if you take x is an element of this set, then x are 1, 4, 9, means in this form that is Qx. If x is an element of this set, then this is Qx. So 1, 4, 9, 16, 25 and so on. If I assume that x is a natural number 1, 2, 3, 4, 5, etc. In that case, square of the natural number 1, 2, 3, 4, 5 are the member of this set. You quote this property of this set. You are writing the element of this set in such a way that in progressive manner the element of this set is the square of the natural numbers. So you can define your set builder form as this is defined as all x such that x is equal to n square, where n is a natural number. You can define this way also. You can define this way also. This is defined as all x Qx such that Qx is equal to n square, where n is a natural number. So in the definition of set builder form, you have given that We are writing the element of the set by characterizing property of qx of each element x. For example, n is there, qx is your n squared, qx is x. When you compare both of that, you will find the set builder form of the given example. Now I am taking another example. You write the following set in set builder form. Second, set A is defined as 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7. So your A is defined as all x such that x is equal to n upon n plus 1, n belongs to n, and 1 is less than or equal to n is less than or equal to 6. You can also compare with this. Your n is your x and qx is x. When you replace qx as x, x as n, you find the similar property of this set. So this is in set builder form. Now, your first exercise of NCERT textbook is totally based on this property of sets, representing the sets, how you represent the set in tabular form, and this element belongs to the given set, this element belongs to a particular set or not. All this kind of question is given in your first exercise. Now I am taking some questions of first exercise. In first type of questions, you have to take whether the given collection is a well-defined collection or not, and whether they form a set or not. Your first question is the collection of all months of a year beginning with letter J. This is a well-defined collection, of course, because the months which are beginning with J is January, June, July, all that. So it is well-defined collection, therefore it is a set. The collection of 10 most talented writers of India. Again, most talented, this word is not well defined because the meaning of most talented writer varies from person to person. So that's why this is again not a set. A tennis of 11 best cricket batsmen of the world, this is also not. The collection of the team of 11 best cricket batsmen of the world, best word is also not well defined, therefore it is not a set. This collection will not form a set. The collection of all boys in your class, of course it is well defined because each member of this collection is the member of your class, so that's why it is well defined and this is a set. Now you see that now I am taking another question. Let set A equal to 1, 2, 3, 4, 5, 6. Now I am putting some question. You have to insert belongs to, does not belongs to. 1 A. Second 8 A. Third 0 A. Fourth 4 A. Fifth 2 A. Sixth 10 A. Now you find out whether we put the symbol this read as belongs to and this does not belong to. If the given element present in the set, then this symbol comes at this place. And if this element does not present in the set, so your second symbol will come here. When you observe the given set, 1 is a member of the set A. 1 is the element of the set A. So what you will write here? Belongs to or does not belongs to. If 1 is a member of the set, you write belongs to. If, for example, in third, 0 does not belong to, because 0 is not present in the set A. So here does not belongs to. So in first case, you write belongs to. In second case, 8 does not belongs to, because 8 is not there, 0 is not there, the 0 does not belongs to, 4 is there, 4 belongs to, 2 is there, 2 belongs to, 10 is not there, so 10 does not belong to. So this kind of question is there in your first exercise. Now another kind of question, you have for a given set in roster form, in tabular form you have to write, then into set builder form. I am taking some examples for that also. To represent the given set in roster form to set builder form, or set builder form to roster form. Three, 6, 9, 12. A set A is defined as 3, 6, 9, 12. You have to write this set in set builder. This is given in roster form, so you have to change it into set builder form. How will you do? See that. First you observe the characteristic properties of the elements of the set A. When you read the table of 3, 3 1 is 3, 3 2 is 6, 3 3 is 9, 3 4 is 12. So in that case all the elements are in the multiplication table of 3. So when you keep this thing in your mind, then I take the natural number 1, 2, 3, 4 in that case, and when you multiply the natural number 1, 2, 3, 4 by 3, then you will get the element of the set A. So your set, it's set builder form. It's set builder form is the set A equal to all x such that x is equal to 3n, n belongs to n, and 1 is less than or equal to n is less than or equal to 4. So I have given you the definition of set builder form. We compare this with that. This is defined as all x such that qx. When you replace x by n, qx by x, replace x by n and qx by x, you will get the same thing. So this will be satisfying the definition of set builder form. So therefore this is the correct, because the condition is true. The condition for qx is true. So that's why this is the set builder form of the given set A, which is given in roster form. Now second example, I am taking another example. B set B equals to 2, 4, 8, 16 and 32. Now you see, while doing all these things, you have to observe the pattern of the given element of the given set. What is the pattern given in the question? You observe that point. Here 2 to the power 1. 2 to the power 1 is 2. 4, it is 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16, 2 to the power 5 is 32. Means you are taking the element of this set as a power of 2. So you can write your set this be as all x such that x is equal to 2 to the power n, and n belongs to natural number. 1 is less than or equal to n is less than or equal to 5. Again you observe that when you take n as x and x as qx, your condition for qx is true. So that is the correct set builder form for the given set B, which is given in roster form. So I think this is sufficient to you. Now I comes to types of set. First, empty set, null set or void set. So you remember that all this word send us a message. There is no element. When I ask my class, the student of my class, move out from this class, so your class will be empty. It has no members. Your class is without a student. Something is without that. If I told you to make a collection of boys whose heights are more than 7 meters, remember 7 meters, their heights are more than 7 meters. Is it correct? Can you find a boy whose height is more than 7 meters? So all these are the example of empty set. It has no element. A set with no element is empty set. It is denoted by the symbol phi, or use curly braces and you don't show any element inside it. Now I am giving you some note. First, empty set is a subset of every set. You know that. This is very important point. Empty set is a subset of every set. Later on I will tell you about the properties of subsets when we say that a set is a subset of another set. So this is empty set. I have given you example of empty set. Next one is finite set and infinite set. Finite set, second. This gives you a sense. Finite, countable. You can count the student of your class. You can count the student of your school. And when I say you count the leaves of the tree, is it possible to you? So finite gives us a sense which is countable. Finite sense set means which is countable. whose elements are countable, which can be counted on our fingers, finite set. Set of natural number less than 5, a finite set. Set of natural number less than 5, a finite set. It has 4 elements. You can count it easily. So that is the concept of finite set. Another is third, infinite set. It again send masses whose elements are uncountable. How many animals in the forest can you count? It is uncountable. Infinite set whose elements are uncountable. Are uncountable. We cannot count. Set of natural numbers n and so on. It is uncountable. Set of real numbers uncountable. Set of rational numbers uncountable. Set of animals in the forest uncountable. Set of leaves of the trees uncountable. So next point is equal sets. When we say, I will tell you the difference between the equal sets and the equivalent sets. Students are confused when we say two sets A and B are equal. Equal sets. If the elements of set A and set B are identical, what is the property of identical elements? They are same in all sense. Then you say the elements of the sets are identical. For example, set A is 2, 4, 6, 8. Set B is defined as all x such that x is equal to 2n, n belongs to n, 1 is less than or equal to n is less than or equal to 4. Equal sets. If sets A and B have identical elements, then we say that A and B are equal. This is the definition of equal sets. Now you observe that you find that whether the elements of A and B are identical or not. You observe that. 2 is here, 2 is in B. 4 is in A, 4 is in B. 6 in A, 6 is in B. 8 is in A, 8 is in B. So in this way, the elements of set A and B are identical. They are same in all the sense. So this implies that A and B are equal. When you find the case of this thing, they are equal sets. Now another, equivalent sets. A set A is given as 1, 2, 3, 4. Another set B is given as 5, 6, 7, 8. Now you tell me, one is in A, one is not in B. 5 is in B, 5 is not in A. Can I say A and B are equivalent? Equivalent means they have the same number of elements. When two or more sets have the same number of elements, then you say that they are equivalent. That is the definition of equivalent sets. So they are equivalent. Can you say they are equal? No. Can you say this example is equivalent? Example of equal sets are equivalent? Yes, because 4 element is there, 4 element is in B. There are 4 element in A and B both. So equal sets are equivalent set. But converse is not true. Two sets A and B are said to be equivalent if number of element in the set A equal to number of element in B. Now note that if sets A equal to B, then this implies that number of element in A equal to number of element in B, and implies that A and B are equivalent. Means property of equal sets have the property of equivalent set. But in this case, since here number of element in second, in equivalent set what happens? Number of element in A equal to number of element in B implies that sets A and B are equivalent. Sets A and B are equivalent. But when you apply the definition of equal sets on the given set of equivalent sets, so you find that their elements are not same in any sense. So they are not equal. But converse is not true. If sets A and B are equal, then they are equivalent. This is your first point. If A and B are equivalent, not necessarily they are equal. Necessary that they are equal. They are equal. If A and B are equivalent, not necessary that they are equal. Now next point. Your second exercise is totally based on all this kind of contents, and I will discuss it with you tomorrow. That's all.